Okay, good morning everybody. It is 11:17. Alright, so let me do a real quick review. Yesterday we talked about this. Circumcenter means a circle going around the outside of a triangle. We found the center of the circle, right? By doing these perpendicular bisectors. And then we were able to find the center of the circle and draw the circle around. The lesson was about the radii of the circle, where they're all equal. And then we also looked at yesterday an in-center where the circle was on the inside. I used all of these angle bisectors, so that this angle is equal to that angle, this piece is equal to that piece. And when we did all those, we came to a center point called the in-center, and then we were drawing a circle on the inside of the circle. All the radii are equal and perpendicular, and that was our lesson yesterday. But today is different. Same kind of thing, but with different words. So today, we're going to talk about median. So what is a median? Median is a line segment from the midpoint, okay, midpoint, let's see, measure that, about 12 point, maybe 12, and maybe half of that is 6. That's a midpoint. Let's call that X. A, B, C. X is a midpoint, which means this side is equal to that. And then 2, the opposite angle. I'm just going to draw it in from there to B, angle B. Now that's different from yesterday, because yesterday the line did not go through the angle. It went perpendicular. That's not perpendicular. It doesn't even look straight up and down, but it goes from the midpoint to the angle. Different than yesterday. Okay, so now if I do the same thing on this side, I'm going to look for the median. So midpoint, oh, that's maybe pretty close to about 9.8, maybe 10. Oh, maybe half a 9.8. What's that? A 4.9 maybe. 4.9 is about there. Let's call that Y. And I draw that in. Okay. And then finally, we'll do the same thing. That side's equal to that side because it's that median. I got about 11 point maybe 2. Half of that would be about a 5 point. What about a 5.6 maybe? Okay, and if I draw that in to see, all three of these should intersect in a single point, and they do. They do, and that right there is called the centroid. Okay, so that's called the centroid. So point P is the centroid. Now, there's no circle. There's no circle, okay? It doesn't even have a word like a centroid. It doesn't have anything like the center. It's actually the balance point of this triangle. If I had to balance on my finger, if this was a piece of metal, that's actually like the balance point, okay? It's like the middle of the triangle, okay? Now, let's take a look at the next one. And there is something about this we're going to talk about in a little bit, okay? I'm going to come back to this. Okay, the next one, the altitude. So we're going to construct this thing called the Orthocenter. When you get the Orthocenter, we're going to find the altitude. What is the altitude? Well, it is a perpendicular line, to the opposite angle. All right? So if we took a look at what we did yesterday, that's a perpendicular line, but it didn't go to the opposite angle. So today we'd have to do like this. So we're going to go from the angle straight down. So I'll go ahead and label this. And my ABC. Hold on. This is my triangle A, B, C. And let's do, first of all, altitude. Now altitude means like how tall it is. So if I want to do this at 90 degrees, straight down, right? Be right about there maybe. Okay. Now, this should seem really obvious. Okay, what do I mean by obvious? I'm going to tell you in a second. Okay? Look at the difference. Look at the difference. This was yesterday. Went through the middle. This side is equal to this side because it's a bisector. This is a perpendicular bisector. Did not go through the angle. Today, this is perpendicular. Yes, it goes through the angle, but that is not equal to this. So it does not bisect this. But it does go through the angle straight down. That's why the altitude means the height, like the height of the triangle. Okay? Let me do the other angle. Okay, so I'm going to turn my paper. Same thing. I want it to be perpendicular, so I'm going to use my protractor to get my 90. Oh, where did I put my protractor? Here it is. Okay, so I'm thinking 90 degrees. Let's see, 90 is right about maybe there. All right about there. We draw that in. There's my altitude from point C. Okay, and then if I turn my paper one more time, that's 90. And again, those two don't look equal. They're not. Okay, they're not equal. And then if I do the same thing from A, and I want to do 90 from A, okay, let me get 90, 90, 90, move it over, maybe right about there. Okay, and if I draw that in, all three should end up intersecting in a single point, and that single point is called the orthocenter. Again, those do not look equal. And altitude, all an altitude does, altitude is goes from the angle straight down. From the angle straight down, okay? Unlike perpendicular bisector, sometimes it doesn't even go through the angle, okay? Now, that's called the orthocenter. So let's call this point P. There's my point P. And point P is the orthocenter. P is the orthocenter. There's nothing really special about the orthocenter, but we can find it, okay? But I do want to go back to the centroid. The centroid is like the middle of a triangle. It's like the balance point. But what it does, it breaks things into thirds, okay? So this point cuts the line segments or my medians into thirds. 1/3, 1/3, 1/3. Okay, let me show you. If you measure this, this is about 3.3. Here's another 3.3 and another 3.3. So there's an invisible line between the two of these. This is a third, and a third. A third, a third, and a third. So if it turns out, like say this is 3.5, I just measured it. This is 3.5. From here to here is 3.5, and that's also 3.5, okay? Cuts it into thirds. If this is about 2.8, 2.7. 2.7, that's also 2.7, and that's also 2.7, okay? Now, if we know that, let's take a look at some of the notes I have for us today, okay? So, let's check it out, okay? Now, here's my notes. So today's notes, let's continue with this. We're going to talk about my centroid and my orthocenter. Where the centroid is made by my medians and my orthocenter is made by the altitudes. Okay, so a median is simply a line segment, from the midpoint to the opposite angle. Okay? And if you did all of those, you find the centroid. So point P here is the centroid. So it's the intersection. Centroid is the intersection of all three medians. Okay, so median. to the middle, okay? Median to the middle. So I know that this side is equal to this side. I cut it in half. It's a middle. It's a median, okay? It's a median. It's a median. I cut it in half, right? It's a median, so I know that this side is equal to this side. It's a median, so we cut it right down the middle. So I know that this side, this piece, is equal to this piece, okay? But it also goes to the angle, okay? So what we know is we learned that it cuts it into thirds, okay? Into thirds. So into thirds. All right, so here's how I do it. This is the short side, right? This is 5. So that means this is also 5. And this is also 5. That really means then LP is 10. Let me draw it in. So that means really LP is 10. So LP is equal to 10. Okay, I know this 12, this short piece, this 12 could have been cut into 6, so this could have been a 6, a 6, and a 6. So I know that SP could be 6. And finally, if I know the whole length of this is 18, right? The whole length of this is 18. The whole thing is 18, and I cut that into thirds. Take 18 and cut it, divide it by 3, take a third of it. I get 6, which means that this piece is 6. This is 6 and this is 6, which makes the whole thing 12. So I can say then that QP is 6 and PN is 12. Okay? All right, let me turn my page. Okay? Turn the page. The Orthocenter. Okay, so now what we learned about the Orthocenter had to do with the altitudes. Okay? So the Orthocenter had to do with the altitudes. And the altitude is simply a line segment, a perpendicular line segment from a side to the opposite angle. Okay, let me get my picture again. All right, that's what we drew. Here it is, straight perpendicular, straight up to the angle. It does not cut it in half, but it does make it at 90. Okay, and so the orthocenter is just simply the intersection of all 3 altitudes. Okay, now let's do one. Okay, so let's graph this. So I'm going to go ahead and go -2, -1. There's point A. 1, 2, 3, 4, 5, 6, 7, 8. There's B. 1, 2, 3, 4. -1. There's C. Okay, let me go ahead and draw in my triangle. I have to draw my triangle right now. I like to color them in too because it makes it easier for me to see them. If I color them in, I know I like colors. There you go. Nice little verde y azul. Okay, now let's see what we got. Altitudes. So we go from point B, 90 degrees. Put it straight down, right? So one altitude is right here. Right? There's one altitude, 90 degrees. It does cut in half, which tells me it's an isosceles. It doesn't have to. Okay, altitude. Now, to do the next altitude, we got to be a little bit smart. So let's see. What's the slope of this line? Seems like the slope of this line is up 3/1. If it's perpendicular, it's going to be the opposite. So it's going to be down 1/3. It's going to look like this.
Same thing here. I'm going to go from A to this side. It's going to be perpendicular. Let's see what the slope of this one is. This one's down 3 over 1. Opposite slope. Up 1 over 3. And I found my Orthocenter at the point 1, 0. Okay, so your journal, today's homework. You're going to look at this. If it's centroid, it cuts it into thirds. Okay, if you're going to find the Orthocenter, then you're going to have to do the graphing. We're going to find the altitudes, okay? So that's your assignment. Good luck, and I'll talk to you guys soon.